Magnetic resonance imaging is frequently used in the diagnosis of a variety of medical conditions. Metallic objects, including orthodontic appliances, can produce artifacts on magnetic resonance images, which are more severe with higher resolution scanners such as 3 Tesla scanners, the current standard of care. To circumvent this problem, fixed orthodontic appliances and fixed retainers are often removed before a planned magnetic resonance scan or removed in emergency rooms of hospitals before an urgent MR examination. This delays timely diagnosis, interrupts orthodontic treatment, and increases the financial burdens and risks potential damage to the enamel. These issues led to the aim of the study, which was to investigate in vivo the influence of commonly used orthodontic appliances on the extent of artifact formation and the diagnostic quality of the MR images of different regions of the head obtained by a 3 Tesla magnetic resonance scanner.
We recruited 10 adult volunteers after institutional ethics approval was obtained. The commonly used orthodontic appliances studied included stainless steel brackets and molar tubes for all teeth, ceramic brackets with no metal parts for all teeth up to premolars, a combination of ceramic brackets for all teeth up to premolars, and 18-8 type stainless steel molar tubes for 6s and 7s, and finally mandibular K9 to K9 18-8 stainless steel multi-stranded wire retainer. These appliances were incorporated into well-fitting clear Essex retainers, which were custom-made for both arches for each subject. Magnetic resonance scans were then acquired for each of the 10 subjects wearing the Essex retainers with 4 selected appliances in random order. The sequences used included sagittal T1 weighted, axial T2 weighted, axial gradient recalled, axial diffusion weighted, non-contrast axial magnetic resonance angiography, and axial fluid attenuated inversion recovery. The resultant images from nearly 14,000 image slices were then independently analyzed by 2 neuroradiologists.
9 regions of the head were assessed: base of the tongue, hard palate, body of the mandible, nasopharynx, globes of the eyes, pituitary gland, frontal lobe, temporal lobe, and the brain stem. The extent of image distortion and diagnostic value of the scans was determined using a modified ROC score system in which the score of 3 represented a cutoff for clinical usability. From our analysis, we concluded that ceramic brackets caused minimal image distortions in a 3 Tesla head MRI.
In brain MRI, multi-stranded stainless steel lingual retainers did not cause significant image distortions with any of the sequences. Also, none of the 4 appliances we tested caused significant image distortions in brain MRI on the non-contrast MRA, axial flare, and axial T2 weighted sequences. Stainless steel brackets and buccal tubes rendered images non-diagnostic for sagittal T1 weighted, axial gradient recalled, and axial diffusion weighted sequences. We also found that the combination of ceramic brackets and metal buccal tubes rendered images non-diagnostic for axial gradient recalled and axial diffusion weighted sequences. For sagittal T1 head scans, metal buccal tubes rendered images of oral and pharyngeal regions of the head as well as globes of the eyes non-diagnostic, although brain images remained diagnostic.
It seems very likely that every orthodontist will sooner or later face the problem of fixed orthodontic appliances potentially interfering with their patient's MR examination. Head MR images are differentially affected, and therefore the appliance, region imaged, and the magnetic resonance sequence should be considered before imaging patients wearing fixed orthodontic appliances.